we learned that the area under the curve, okay, so if f was a continuous function which was greater than or equal to 0, and if we were looking for area from a to x, okay, and we had denoted this as a of x, then this was equal to f of x minus f of a, where f dash x is equal to f of x, and small fx is nothing but this curve. Now, this happened when the graph was above the x-axis. Now, what happens if our graph is below the x-axis? Like, for example, like this. Okay. Suppose I want to find out this x. So, in this case, we will reverse the formula. Ax would be equal to f of a minus f of capital X. Because if we keep the original formula, we can notice one thing, that this area is going to be negative. So to make this area positive, because area cannot be negative, we will reverse the formula. Ax is equal to f of a minus f of x. Like, for example, if you consider this y is equal to minus x square, and you calculate the area on 0, 1 again. So this is going to be like this, okay? And this is y is equal to minus x square, and this is x equals to 0. Suppose this is x equals to 1, and suppose we are calculating this area, okay? So here f of x is equal to minus x square. So if you take capital Fx to be minus x cubed by 3, so your capital F dash x would be minus 3x square by 3, which is minus x square. Okay. So f dash x is actually now coming out to be f of x. So if you apply the original formula, which is f of x minus f of 0, you notice that this will be minus x cubed by 3 minus f of 0, which is 0, which is minus x cubed by 3. And if you calculate it at 1, it is going to be minus 1 by 3. So area can't be negative. So either you use the formula Ax equals to F0 minus Fx, or simply you take absolute value of Ax when y equals to Fx is below x-axis, okay? And same process is carried out when my curve is above and below axis, okay? In the same diagram. Like, for example, if I have a situation like this, okay? So we can suppose this is my interval A1, A2, and this is A3, A4. So you find out this area, call it A1. Then you find out this thing, call it A2. And then you find out this thing, call it A3, using the same process. And then you note that area cannot be negative. So therefore, we have to take the absolute value. That's it. Otherwise, what is going to happen is this. Suppose you will have a curve like this. Okay. Suppose you have a situation like this. Okay. And suppose you do not take care of the signs. Okay. So suppose this is going to take plus 3 value. And as this is symmetric to this will take minus 3 value. So you will add both these and you will find the area to be 0. But area is not 0. Area is actually 6. Okay. So whatever is below the x-axis, it has to be made positive. So either you take the absolute value or reverse the format.